In this recording, we're going to learn how to solve trig equations and also trig inequalities graphically using some graphing utility such as a graphing calculator or a dynamic graphing tool like Desmos, which you can access on your phone. So we're given the similar domain as before when we solved our equations algebraically. We're going to solve between 0 and 2 pi radians. We're also going to round to the 100th. It's unlikely that we'll necessarily get exact values here. That's why we're using the calculator. So the first step is we're going to want to get this into standard form. In other words, let's get a 0 on one side so we can look for the zeros, the x-intercepts of this function. Okay, now that we've got all the terms on one side, we're basically going to put this into y1, right? Graph this like y1 equals, and we're going to look for when the function equals 0. Okay, so I'm not really going to have two equal signs on the same thing. We're basically saying I'm going to put this the left side into y1 and see where it equals 0. So let's go to our graphing calculator first and accomplish this. If you don't have a graphing calculator, just play along, because in class on the test, you're going to need to know how to do these steps. So maybe make little notes to yourself. So first off, we're going to want to get in the right mode. Make sure our mode is in radians, because that's what our domain was, right? 0 to 2 pi. Once we've got our mode all set, we can go ahead and enter the function. Notice where I placed the square. You can't fit it in on the calculator between the n and the angle, the n of sine and the angle. So you do sine of the angle, close off the angle, and then square it. That's basically saying square the function, which is the same as sine squared x. At this point, we're going to go to zoom 7 for z-trig. And we can see that we've got this graph. Well, this mark right here is pi over 2 pi, 3 pi over 2, 2 pi. So what we might want to do is change our window so it's exactly 0 to 2 pi radians. Don't have to do this, but I encourage you to do that. Now just hit graph. Okay, so we can see we do not have any solutions beyond 2 pi radians here. We just really have the 1, 2 solutions. Now on a TI-84, I tried this on my regular calculator. It almost looks like there's an intersection point. So on this, we can clearly tell the resolution is a little better here. We do not have an intersection point here near pi over 2. But on your TI-84 Plus calculator, the silver edition, you can't tell that. I'm going to show you how we're going to know that. So basically, we're just going to use this calc tool. So second calc, the trace button, and we want choice 2, 0, because that's going to find the places where the curve has a y value of 0. So it's going to ask me 3 questions. What's your left bound? So I'm going to use my left arrow and cursor all the way to the left of where I want to find. And the first place I want to find is that place right here. So that's a good place. Hit enter. Now your right bound, make sure you're to the right of that place. Hit enter. And then guess. Anywhere close is good. So that'll be fine. And to the nearest 100th, 0.09. So we'll just remember that value. And now I want to see, is there a solution in here at this local maximum? So we'll do the same process. Second calc, 0. Now when it asks me left bound, I want to get somewhere just to the left of that place, like maybe right there. Hit enter. It's asking me right bound. Okay. Move to the right of that place. Hit enter. And then guess anywhere close. And it's saying no sign change. You'll learn more about that in calculus. But in other words, it never went from going, I got to quit out of this and get back in my graph. It never went from having a negative value of y to a positive value of y. Whereas here it did. The curve's coming along, it's all positive values of y, then it hits a 0, then it goes to negative values of y. So it knows it hits a 0, if it goes from a positive to a negative, right? It has to come through 0 at some point. So it didn't have any there, even though on your other calculator it may look like it does. Let's find this place over here. So one more time. Second calc 0. Left bound, somewhere close. Right bound. And then guess. Okay, so 3.05. You might notice some funky stuff over here. That's not what we expected, right? You expected to see a 0 here. Well, think about that. That's negative 0.0000, right? 12 zeros, and in the 13th place, you're going to see a 4, 8. So basically 0, right? This is just sort of a rounding imperfection in the calculator. So those were our two numbers, 0.09 and 3.05. So I'm going to take a screenshot here. And that's what we want. Maybe it's already copied. And I'm just going to put that into our note here so I can draw one, just like you're going to draw one. So we want to establish on our paper how we did this work. All right, now we're just going to do our best to sketch this out. We know we had a point that was just not, it wasn't actually there. Let's take that point out. The point was just a little bit before pi, right? It was at 3.05, and then we had a point here at 0.09. And we're just going to sketch that curve. It kind of went down, came up near here, but didn't quite make it, went down again. And then it just kind of got wide like that. All right, so we had the point here, 0.09 comma 0. We had this other point, 3.05 comma 0. So it asks us for our solution set, and our solution set would look something like this. And I'm going to tell the tool that I used down here. Let me find some space and write that in. We used second calc 0 to find the zeros. All right. Of course, you wouldn't have this on your paper. You just have your sketch showing your zeros, showing the manipulated equation, and then your roots. All right. I'm going to show you now how to do this on Desmos. It turns out it's really easy. So you're going to go to desmos.com. So just go to that website. I know you have internet access because you're listening to this on the internet. You just hit start graphing. DESMOS. So let me see if I can make this viewing window a little bigger. Okay, and we want to put in that function we put into the calculator. So you're going to hit functions over here. You're going to hit sine of x squared. The square tool is right down here, a squared. Okay, so that makes that graph. And actually we wanted a 10 up in front, but that's no problem. We can pop in a 10. And then we want minus 11 sine of x plus 0.9. All right, and the cool thing is, all I have to do, and you can, on your phone or wherever you're doing this thing, computer, tablet, you can see those points. You just click on them, right? 0.09 comma 0. That one came up short, right? It didn't go to 0 at pi over 2. It came to negative 0.1, 3.05 comma 0. So right there, we can uncheck that one because that one's not an answer. All right, so for our second and final example, we're going to solve an inequality here, not an equation. The same idea though. Note as you're writing it down, the domain has changed. It's now from negative 2 pi to 0. So take a moment to jot down this inequality and then get it into standard form so all the terms are on the left side. Play the recording when you're ready. Okay, so hopefully you took care of that. We're going to approach this very similarly on our graphing calculator. Once you've got that entered, we can go zoom 7. Pretty interesting graph. Kind of goes up, little peak, goes down. Kind of cool looking. So we only want to go from negative 2 pi to 0. So let's hit window, and let's have it be negative 2 pi, and then the x max just 0. We'll then hit graph. Okay, so we're interested in, if you recall, the values of this function being greater than 0. So I'm interested in all here, the points where those are greater than 0. So I want to know what's that point right there. I'll do second calc 0, left bound, hit enter, right bound, got to go to the right, and we found our 0 at negative 0.51. So we can then come back and make a sketch of that. So you'll jot down on your papers a little sketch. Okay, keep in mind we have to answer this question. It's an inequality, so we want the interval between negative 2 pi and 0 that satisfies that inequality, for which the left side is greater than 0. So we really want all the way up until that point. So within that interval, we want negative 6.28, including that side, right? So a staple here, a square bracket, includes that point. All right, goes all the way up to wherever that point exists off my graph, up until negative 0.51. Now I want it to be just greater than, so I don't want to include where it equals 0, so I want a parenthesis there, right? If using set builder notation, you'd have something like x such that x is between, in other words, it's greater than or equal to negative 6.28 and less than negative 0.51. That's set builder notation. Either one of those forms is fine. I'm going to stick with the interval notation right here. Showing that in Desmos, very simple. You're going to do a little modification of this. Okay, we've got our graph there. Sine x, sorry, I wanted a 2. All right, all I need to do is click on that point right there, and there I have it. It calls that one negative 0.51. I could have sworn on the graphing calculator we had something slightly different. I guess it was a 515 by the time they round theirs up. So, all right, you can kind of see here, if we look at this graphing calculator, this one is at negative 515. If we round to the thousandths place, they're right. They rounded, and then we're going to round their rounded answer, so you can see there's a little error that we're introducing there, but we're just going to have to live with that. Okay? Thanks for watching.